I'm pretty chuffed by my various successes in the process of making all these videos. I've made 17 of them so far about NixOS. And as a result, I'm quickly becoming a Nix fanboy. Now, love is fickle. And in a few years, I'm sure I'll shake my head at my former self disapprovingly, knowingly, at my naivety. And I'm sure I will discover all the things that are wrong with Nix. But right now, I am in what personality disorder specialists might call the idealization phase, where nothing can be wrong with Nix. That will end. I've been through this before, but right now I'm not devaluing Nix. I'm idealizing Nix, and but the difference between me and someone with personality disorder, although don't take it on my word, is that I know that everything has trade-offs, and everything isn't perfect. The things that I idealize are not perfect. So what has gotten me most chuffed about Nix, and what I'd like to describe in this totally pointless otherwise video, is the idea that in Nix, it is layers that are based on good fundamentals. So there are layers in the system that are fundamental to the overall workings of Nix, like a derivation, and the idea of a store and other stuff. Now, I am no expert by any means in this. I'm just a podunk developer who happens to have fallen into Nix. But what I'd like to believe about myself is that I can recognize when things are markedly better than the status quo. Maybe that's all I will say about my skills as a tech person. I think I can quickly recognize, or more quickly recognize than 50% of people, that something is total bullshit or not. Nix is not total bullshit, and one of the reasons it's not total bullshit is this layering concept. So it's based on these really good fundamentals like a store and derivations, and then it has this other stuff on top of it that implement concrete realizations of Nix as a package manager on top of these very general ideas. And I'll go into more detail about that, but it's human nature to fetishize stuff. I mean, it's just human nature to fetishize anything. There are people who love, I don't know, tops 10, or like, I don't know, AS400 or something. I don't know, whatever. But fetishizing stuff really, if you don't have an eye on the fundamentals of what makes something good, and you like the outcome. Let's say you really like the outcome, and the outcome really drives you. The presentation of the thing is like, wow, this seems really easy to learn, but the fundamentals are bullshit inside of it. It is really hard to imagine it succeeding in the long term. The outcome might be good. The raison d'etre might be good, but if it's not implemented in a way that you can sort of scrape things off and kind of start them again, when you make a mistake, because people make mistakes. They make mistakes all the time. The entire world is made up of mistakes. We make mistakes way more than we make the right decision. And the whole practice of software development and the whole history of software development, all the things that we do, is just a testament to the idea that we make mistakes. And there are, things succeed even though they're not based on good fundamentals. Like, examples. I'm sorry to anybody I offend with this, but I'm just going to say it. Windows is not based entirely on good fundamentals. It has some really good bits to it. It has some of the concepts that it inherited from VMS uh, that are useful. Permissions and ACLs and stuff. Some things are really good, but then it has all this other crap in it that came from DOS, like the idea that there's software installed globally, and I mean just weird stuff that was kept inside of Windows when they switched off of DOS because it was expected by the users. The idea that there are users in Windows. The original Windows had no concept of permissions or users or anything like that. It was just you could do anything. And when Windows inherited some of the VMS stuff, it got the concept of users, but it had to retain some of that cruft, some of that feeling of DOS, where you could do anything. And that really, the split brain phenomenon really made it difficult to reconcile that it was fundamentally sound. Another example, and again, please don't take this personally, anyone listening to this, but I'm going to say something like Rails, like Ruby on Rails. Ruby on Rails, was sort of a phenom in the 2010s, and sort of pioneered this idea of convention over configuration, and people liked the outcome of it. But as far as I can tell, and I think time may have borne this out, maybe, people don't seem to be writing new Rails app. People aren't energized by Rails and Ruby and that stuff. And that's because the fundamentals, the stuff in between the outcome of Rails and the beginnings of Rails was pretty messy. There's monkey patching and there's just weird crap happening. Like it's not you can't take that and say, hey, here's how this thing works. Oh, and by the way, it happens to patch the interpreter. It's just it can't do that. You have to kind of like take a step back, scrape that bit off, and you might have to throw away the language to do that. Like whatever, man. You know what I mean? But these are things that are not based on good fundamentals, and because of those, they can't really be fixed. They can only be thrown away. Right? There are ideas in them that can be reused, but no software. Maybe even some of the concepts of them need to be revisited, like the convention over configuration stuff. That never made too much sense to me. You may disagree. Things that have good fundamentals. One of the nice things about using things that have good fundamentals, I will offer up Unix as an example, is that you can quite easily become, there's this concept of a 10x developer. I won't claim that you can become a 10x developer by using Unix, because you can't. But you can become a 5x developer by using Unix and maybe some other things that have good fundamentals. And when I say a 5x developer, you don't have to do much to get there. You just have to use the right stuff, and being able to recognize that some things have great fundamentals is a way to do that. The reason, I've sort of expounded this on in a prior video about how people have a tough time learning new things. And the reason they have a tough time learning new things is because they have this idea that knowing that thing is sort of a immutable attribute of a person. Like it just, some person received that wisdom somehow, and they didn't fight to know it. They just have it, and it came naturally to them. And as a result, they feel stupid and are afraid of looking stupid in front of other people when they try new things, because they don't know them. And that fear prevents them from progressing. And that is that's sort of the head of Zeus. The idea that this knowledge just comes from the head of Zeus. The only way in which that there is one exception in which the head of Zeus fable is true, and it gets you to 5x, or maybe 2x. I don't know, whatever. Just name an x. And that is using things that have good fundamentals, because you just naturally inherit some of the good practices of the authors of those things. It certainly won't get you to 10x, but 5x that's pretty good. That's not bad. That's all right. 2x is good. It's not 1x. There are a lot of 1x developers, man. A lot. So I mentioned Unix. I'm sort of mentioning Nix and Unix in the same breath. And the reason I do that is because Unix had this sort of, this trope is a bit tired, but it had this concept that everything is a file, sort of. I think people overestimate how important that feature of Unix is, but in this sense, anyway, at least for the purposes of my convincing example, I think it might be true. At least it was true enough when it was created. Now, you got to understand, in 1970, 69 or 67 or whatever Unix was first conceived, we're talking about machines that had, 4K, 16K, maybe 32K of RAM, on a PDP system. And there was no real networking to be found, Also, there's no such thing really as a standard operating system. Unix was one of these operating systems that came from this culture where in PDP, in digital mini computer stuff, there were 1,000 operating systems, and none of them were standard. Unix just happened to come from that heritage, and sort of the rest of the herd, at least some of the rest of the herd. There are other systems that have other legacies, like the BCPL language is based in some other system that's sort of a peer of C, and it had some downstream effects like Amiga stuff. Original Amiga OS was written in that. It wasn't written in C, but eventually that stuff got culled. Even in Amiga stuff, it was re-implemented in C because people just didn't want to think about that alternate conception of the universe. So when I say that the Unix had everything as file thing is useful to my argument, what I mean is that let's take, like, for example, a semi-contemporary system. I know it's not at all contemporary. This is much later, but something like, honestly, I'm talking bollocks here because I don't actually, I've never used such a system, but I've known developers that were, deeply committed to IBM's like AS400 system. And IBM's AS400 system takes a very, very different view of the world than everything as a file. There are files, sort of, in AS400, but more fundamentally, kind of everything is in the database, or everything's a field in an application. And I'm sure some implementation of files was also there. But, so given the files existed both on Unix and whatever AS400 was, which is recognizably the more fundamental? Is it fields and databases, or is it files? And which was realizable at the time that Unix was created, and even when AS400 became popular, and has since, except in airline stuff, fallen out of favor. Well, the answer is files. So, even though I think the trope is way overused, I think it's true enough, at least for purposes of my argument. So they were very limited in what they could have as fundamental. You know, the idea that everything's a file, that there are these sequential blocks of data on disk that are read by name, you know, and that even a directory was a file, and like control things in the operating system were files and stuff. Well, it was sort of not revolutionary, but it was consistent enough inside of the initial implementation that people liked it, and it fit their brain. So, but they didn't have much. Again, we're talking, you know, 4K, 16K, 32K of memory. This is a very different Unix than the one we have today. Okay. So the idea of everything is file, well, everything isn't a file. You know, we have other way higher level concepts that need to become fundamental. They currently aren't fundamental. And in 2022, the power that we have available to us, you know, lets us consider the idea of what should be more fundamental a little more broadly. We have gigabytes of RAM. We have gigabits per second of network transfer. We have a universal network. I mean, we have all these resources that were not available at the time that Unix was created. It's still a crapshoot as to what those other fundamental things are, but we have more headroom to consider other fundamentals. We can make other fundamentals where we're not always sort of tied to convention. We can, or we're not always reinventing how things are built, you know, and how things, in particular how software is built and how software is compiled and stuff. As Unix evolved, it kind of elided a bunch of messy stuff that was originally too ambitious to consider fundamental. But for reasons I just mentioned, we can revisit that. You know, in particular, there was no idea of a package of software in Unix because there's no network. You know, there's no, you know, various distributions of Unix had proprietary ways to do this. Like HPUX had packages and, you know, all sorts of stuff, but there was never anything that really felt fundamental in a way that made sense to people, like, you know, the Unix everything is file concept. But Nix is one of those things that broadens the definition of what we might be able to consider more fundamental. At least to me, that's what it does. It defines other things other than files. That's fundamental. It says, hey, on top of files, we also have these, you know, this is the layering concept. We also have this concept of derivations. And derivation describes some software and its dependencies. And, you know, this is a notion I can get behind, because this we always have to do this when we deploy software and when we write software. We always have to do this. We always have to know how this goes. There's no currently you know, recognized way other than convention that we do this. I often, like in the past, I've often like sort of mentally shook my head at people who kind of fetishize things like a file system layout, like what goes in bin, what goes in user bin, because it was obvious to me in Unix shortly after using it for any period of time that it's totally arbitrary. It's only by convention. Any fight over whether things should live in various places is plainly and incontrovertibly pointless to me. The file system layout is not fundamental to Unix. You could even imagine a limited but still useful version of Unix didn't even have directories. There's one exception to this that well, I'm sure there's more than one, but one I can identify, which is file system layout convention is not totally arbitrary in the case where software has to find its dependencies. The dependencies of one piece of software they might currently, like, you know, on Linux, might live in /lib, a subdirectory of /lib, a subdirectory of /user/lib. It's not a science currently, even with a standard space. It might even be totally somewhere different. You have to pass in compile flags and all this crap. But the exception to the rule of this plainly and incontrovertibly pointless fight about file locations, conventions about directories on the file system, is building software. The conventions make it at least conceptually possible to build software that works across Unix-y platforms, at least. The systems are similar enough that with a little bit of fuzzing, you might be able to get something built on different distributions of Linux and maybe FreeBSD and maybe Mac OS, and it's still very difficult. There's no science to it. It's all just crap. I mean, it's all just keeping track of the machinations of new releases of these distributions that make arbitrary changes to the file system layout. So the result isn't particularly good. It just makes it possible. I mean, the convention makes it possible, and it makes slightly less inconvenient than having no convention at all. So note that the time between when Unix began to be developed and when Nix began to be developed, which is around 2003, I think, is roughly 30 years. I mean, we've had 30 years of finding dependencies by convention. And I don't think anyone could really look at that and say, boy, we nailed it. But the convention is great. It's okay. I mean, it got us through 30 years. But now we have machines with massive processing power and massive amounts of disk storage and just floodgates of networking. And we can dream bigger about more fundamentals, and a packaging dependency fundamental on top of the concept of files in Unix is one of those things. And we've had sort of the pessimist view of this is that it's been a long time since Nix was started. It's been 20 years almost, and we haven't really. Nix is becoming popular, but it is not de facto right now. Now older systems, have like I was saying with HPUX, have come up with packaging solutions, RPM stuff, that are I will say all derivative of each other in a way that is proven unprofitable. They have a way of managing dependencies, and they have a way of installing software globally that solved a problem. But the problem is much bigger than what they solve. For deploying software that you develop, deciding where it goes in the file system is really not that important to me. I don't care. Okay, I care that it exists and it works, but I don't want to think about exactly its right location in this arbitrary hierarchy of directories. It is not interesting to me to think about that. So Nix takes a stab at sort of saying, yeah, hey, you're right about that. It's not all that interesting. We're going to just jam it in this store. It's not all that interesting. And that is attractive to me. And I can't, despite the fact that Nix is not like conquering the world at this point, I can't think of any other system that is so different from the status quo that's been so successful in practice presently. The way I think about this is that I think Nix sort of has this Python circa 2004 feel about it. I come from the Python world, and I started to write Python in 1999, and no one knew what Python was. People used Perl to write web apps, and Python was this you know oddity. Since then, and this is evidence in my own mind of why I believe that I can recognize the fundamentals of good things. Now, I didn't choose Python for that reason, but I stuck with Python for the reason that it was good fundamentals. Um, Python is good fundamentals. Python the language is really pretty uh, it is useful in a lot of contexts. And if I hadn't uh, used Python when I did, my life would be much different than it is now. I would probably be a lot poorer, although I'm not very rich at the moment, but I would be even poorer, and I would certainly not have as much knowledge about some of the good practices that Python has that I learned about. I might have different ones, but I think I've been able to wring out every last drop of benefit that choosing that thing. I became for some definition, a 5x developer as a result of using Python. In comparison to the poor saps that were using less things based on weaker fundamentals. So anyway, that's my opinion. Anyway, so there's an irony to this, in that I'm comparing Nix to Python, and I'm comparing it to Python circa 2004. It was popular. It had some take up, but Python in 2004 is not the Python of 2022. You could submit a talk for PyCon in 2004, and it would almost certainly be accepted. You didn't have to put on a dog and pony show. You didn't have to be a known quantity. You didn't have to have a social media presence. There wasn't any social media back then to be part of the formal Python community. It has grown now. It is a much different animal. I believe that I think Nix is going to get there. I think it has fundamentals to get there. So I say it's ironic that I feel it's ironic that I am comparing Python to Nix, because Python in its base purpose is actually kind of the opposite of Nix, or the base outlook on life is kind of just the direct opposite of Nix. Python's core developers are pretty hands-off when it comes to how Python code should how Python software that is distributed. Python software that is distributed should declare its dependencies. They are historically have been pretty. I'm not sure I care about that problem so much, and they've punted to community members that are less involved in the core to define the things that would make that possible. And that is really kind of, in my opinion, that has been a problem in Python. So this is why I say it's ironic that I'm comparing the two, because they're kind of opposite. But maybe it's not that ironic, because I'm the author of at least one framework that was written in Python. I'm the author of several frameworks. One of these frameworks was written in Python that was kind of an early adopter of like a relatively early revision of the flawed way that Python software has evolved to declare its dependencies, Python software distributions, and how it gets software installed. And people really were not jazzed by this. A lot of the docs I wrote for this framework were not documenting my framework because the fundamentals weren't so good, weren't great about how dependencies got installed. A lot of my docs went into explaining or apologizing That's a better description of it, of why things needed to be done a certain way. But I was a believer in the idea that you don't just ship everything as one big ass tarball and hope for the best. I believe that you could ship software and deploy it in layers, as I described earlier. With what we had tools at the time, which was, I guess, 2007-ish, 8-ish. This was sort of true, but it was relatively new, and my docs, went into a bunch of it. But I think a lot of people saw that and went, ugh, because other competing frameworks like Django, they just did not. They eschewed the idea of dependencies entirely. They would have you ship, at the time anyway, they would have you ship everything as one big tarball, including the dependencies. So, this fit people's brains better in Python because people weren't used to the idea of installing software and having various packages that had dependencies that that was factored that way. So, amongst other better reasons that my framework was not considered was not welcome with open arms amongst the what do you call them, the hoi polloi, as you say. Amongst other better reasons, this was one of the reasons my framework's popularity was limited, and my ego, my very important ego, was bruised by this. And so software and dependency installation at that point sort of became naturally kind of personal. Ricer. Listen to that. That's bullshit. Anyway, yeah, I know it's politically incorrect. I get it. So, the idea of how software dependency installation worked was kind of personal. That being said, I had no idea how to make it any better. It just wasn't something. It wasn't my bag. It was good enough. It worked, to do my job, to try to layer this stuff in a way that wasn't just one big ass tarball. I just had no idea to do it right because I'm not that smart. Now, the lack of irony is that Nix is a stab at doing that right. And as I mentioned before, I like to believe, I'm probably incorrectly under the presumption that I can recognize when things are markedly better than the status quo. I think Nix is. Declaring new fundamentals like derivation and stuff, as I mentioned before, still pretty tricky. I'm not sure it's going to survive the test of time, but it feels more right than what exists now. And it's still more art and science. Who knows? I don't know much about Nix. I don't know the language very well. But I just have this feeling that it has a better set of fundamentals than what has come before it. I also am chuffed again by the idea that I have, although I don't know the language, I have a general idea that Nix, the language, is really simple. The reason I have that idea is because it can be described in a couple pages. There's not 200 pages of documentation describing Nix, the language. There's only a few. And I believe, I've read at least parts of the PhD thesis that it comes from, that a decision made early on by the PhD thesis author is at the heart of why this is. So it's very tempting when you come up with a new system to try to squeeze everything into that system. Everything must be done in a functional language. I have this new language. You're going to need to re-implement the world in it. All right, and you're going to need to understand the world in terms of my functional language. This is a losing strategy almost all the time. Very rarely it's a workable strategy. But instead of doing that, as I was saying before, Nix is a collection of frameworks. So there's the concept of derivation and nix-store. It ends there. Okay, that layer of Nix is fundamental. There's another layer of framework built on top of it, at least for Unix, is built mostly in shell. It is implemented. The thing that makes Nix the concept and the quote unquote package manager generally, the thing that makes it concrete is the shell that lives. There's a bunch of other frameworks that live on top of this concept, and this is what makes Nix the package manager into Nix the package manager for Unix. So you can imagine writing a Nix-like system. I'm sure people have tried it already. Nix-like system for Windows instead, or Nix for God knows what. I can't even think of any other operating system. So the reason that this is attractive to me, if you do one of these layers wrong, you just get rid of it. I'm using Nix right now. I have some good idea that the knowledge I gain by knowing how the nix-store works, and generally just the idea of grasping the concept that this is a better status quo than the convention of file system locations that we have about how to find dependencies, is worth its weight in gold in some sense. But you're always going to get it wrong. I mean, you're always going to write layers wrong. We make mistakes all the time. But one of the nice things about it, I don't have to throw away that knowledge. I am not tied to this pile of software that has no factoring whatsoever. That knowledge is eternal at this point. The knowledge that I've gained from just playing around with nix-store. The other stuff that's on top of it, I don't have an opinion about it yet. I haven't really used it that much. The stuff that like the make standard env, make derivation. I don't know. Maybe they're entirely wrong, but that's the nice thing about it. If you do one of the layers wrong, just throw it away. Try it again. You'll have to redo the work that's in that layer and any layer that has it, but you don't have to scrap what's underneath of it. This is why, in my opinion, Rails and Windows don't share this property. You either use Rails or it's the fucking highway. You either use Windows or it's the fucking highway. There are things that you can learn out of using Rails and Windows that have some applicability to other systems, but nothing concrete. You might, again, this is a game of inches here. This is not something where you say, yes, Nix is factored right and Rails isn't, and I can always use the actual implementation of the store somewhere else, and but in general, the way the store is implemented right now seems pretty solid, and seems like it would be a waste of time to try to re-implement it, conceptually anyway. I think the way that Rails does what it does doesn't share that property. It has, there are things you can learn from Rails, but you couldn't claim that any bit of it is something that you wouldn't want to re-implement. I think. I'm sure people will disagree, but that's my opinion anyway. So the difference between that and something like Unix distribution, or particularly in the form of Linux, I think Unix and the Unix and Linux distributions in particular do share this property. They are, if you use a Linux, there are things that you can learn and things that you can reuse from using that Linux that you can carry over to any other distribution of Linux. There are wild, crazy, impractical distributions built on top of Linux, the kernel. NixOS being one of those, the kernel's the only constant to that thing. And it would be silly to re-implement such a thing, although people have other, the FreeBSD exists, and people have other operating systems, Darwin and New Herd, and we have all kinds of stuff. But in general, when it comes to software development, the game is Linux, and it has been for 20 years now. Sorry, Windows, but this is just the way it's going. And if you use any version of Linux, you can carry that knowledge over to other versions of Linux. So I don't think, I don't know for sure, I, you know, this would be prognostication in any sense, but I don't know that Nix's fundamentals are totally right, but I just have a feeling that it's more likely than not that once people start to use something like Nix or Nix itself, or maybe they come in through NixOS, or maybe they use it on top of Red Hat or whatever. The fundamentals, once they understand it, use it, are something people are going to want to throw away. It just solves too many problems. Using it is a one-way street. I'm not saying NixOS will survive like sort of relentless culling of the herd when it comes to fundamentals, but I have a feeling that some form of the fundamentals that are in Nix will be at the heart of quote unquote your next OS. That's going to happen pretty soon. And that, by the way, is why I use NixOS.